Okay, hi guys. So in this lecture, we'll be continuing on seeing more on endothermic and exothermic reactions. So let's get started. So suppose we have this equation. We have Ag getting converted into 2 moles of Pg. Okay, so in here we can say that let's suppose delta H for this reaction is k kilojoule, or we can also write that delta H at constant pressure, which is nothing but change in enthalpy, is x kilojoule per mole. So this is nothing but enthalpy change in chemical reaction. Okay, let's say one more example. We have 2 moles of Ag getting converted into 4 moles of Bg. So heat delta H in this case would be 2 moles of, or rather 2x kilojoule, or we can also write it as change in enthalpy would be 2x kilojoule per mole. Okay, now for a chemical reaction we can write that K1, which is, let's say, equilibrium constant at a temperature T. So for a chemical reaction, K1 is equilibrium constant at temperature T1, and K2 is equilibrium constant at temperature T2. Okay, so we can write that ln K2 upon K1 would be equals to delta RH divided by R 1 upon T1 minus 1 upon T2, or we can also write in terms of logarithm, which is a natural log, which is log K2 upon K1 would be equal to delta RH upon 2.303 R 1 upon T1 minus 1 upon T2. So please remember these two formula. They are very useful formula as far as the domain of JEE syllabus is concerned and JEE examination also concerned. So these two formulas are very crucial. So for endothermic reactions, we can write that delta RH is positive. Okay, and as delta T increases, K2 by K1 would be greater than 1, or K increases. K is nothing but the ratio of K2 upon K1. We may not even write it, just we can say that as delta T increases, K2 by K1 increases, and as delta T decreases, K2 by K1 also decreases, and the ratio becomes less than 1. And what about exothermic reactions? For exothermic reactions, we can write that using the same analogy of the above note, we can write that for exothermic reactions, as T or delta T increases, K2 by K1 becomes less than 1. Okay, and if we write K equivalent as K2 by K1, then we can write K2 by K1, or rather K equivalent also decreases, and as delta T decreases, K2 by K1 becomes more than 1, or K equivalent increases. So now let's say the physical significance of equilibrium constant. constant so we can write that if the value of equilibrium constant is very high or of the order of greater than 1000, then very high conversion of reactants into products takes place. First point is, if the value of equilibrium constant is very high, of the order of 10 to the power minus or 10 to the power 3, then high conversion of reactants into products take place. Okay. Second point is that if the value of equilibrium constant is very low, or we can say K is less than 10 to the power minus 3, then very low conversion of reactants into products takes place. And third point is, if the value of equilibrium constant is nearly equal to 1, then appreciable conversion of reactants and products takes place. The value of K equivalent nearly equal to 1, then appreciable conversion of reactants to products take place. Okay. Next, let us I want to take the next topic in the coming lectures, but let us first at least have a title or some preparation for the next lecture as well. So we'll be talking about calculation of Kp and Kc in the next lecture. Okay. And we'll be seeing that first we'll be seeing a stoichiometric method, wherein we'll be using a simple equation to convert a compound A into two compounds B and C, and we'll be taking initial moles of this compound as M, and they are not present initially, and moles at equilibrium. We'll be taking M minus AX, BX formed here and CX formed here. Okay. So we'll be doing the calculation based on the above concentration at equilibrium in the next lecture. So till then, good luck and goodbye.